So one of our most popular videos was on GC troubleshooting, and during that video I talk about this concept of half splitting, and during half splitting I talk about the idea of assigning the test plot to the detector. So I'm going to show you how to do that. We got a lot of requests to show how that's done. So let me back up a minute. Make sure you check out that video if you haven't. Let me back up a minute and get you to understand that when we're troubleshooting, we're not really sure what the problem is, so we want to sort of eliminate parts of the instrument. An example is we could take off the autosampler tower, make an injection without the autosampler. Another example is that built into the memory of the GC is a fake chromatogram. It's an electronic chromatogram that the GC can send out through the data cable to the data system. So it could be used in data system validations, it could be used for troubleshooting. Let me show you how to set that up. So if you're running the software, and this is the typical ChemStation software, this is B.0403, and in it we have control of the GC itself. So let me first go up here and stop the run that we were collecting before. And now I want to show you how to actually assign the test plot. So historically or traditionally, the GC has two data paths that can come out, signal 1, signal 2, or now analog 1, analog 2. And these data paths can contain different things. Typically, we think of sending out the detector data out the signal paths. So the front injector and front detector go out of A, and the back detector goes out of B, or 1 and 2. So now let's talk about how we actually assign the test plot. So if you look at the software the way it's set up, if we look at the signals, what we'll typically find is that the first signal is set to the front FID, and the second signal is typically set to the back FID if you have two FIDs. So that's what you'll typically see, front signal FID. In this case, we want to do the test plot. So we're going to go up here and we're going to say diagnostics, test plot, apply. Then when we say OK, so now anytime we hit the start button on the GC, it's going to output this chromatogram. And this chromatogram contains 3 peaks, big, medium, and small. It takes 1.5 minutes, and then it keeps repeating itself. So I'm going to go up here and tell the instrument that I'm going to start the run. Now it's waiting for the start button. So as soon as I hit start, we should see the red line appear, which is the 0 mark, and so it zeroes the timer, and now it's going to start in real time running a chromatogram. So the GC is putting out data points in real time, and those data points are being accepted by the data system, and that is what we're plotting. So there's the first peak, that's the biggest one, and then, like I said, it's 1.5 minutes. These are electronically generated; they're not real peaks, but we could use these since they're always the exact same signal. We'd use that for, like I said, validation of data systems or troubleshooting the GC itself. So what's nice is you could zoom in and you could treat this just like you could treat any other chromatogram. We could see the resolution between peaks and so forth, but essentially what this is used for is just to confirm the fact that the computer is receiving what the GC is outputting. So when you're done with that, make sure you remember to go in here and first we're going to go ahead and stop the run, and make sure you go in here and reset signal 1 to the FID, and don't leave it as the test plot, because sort of a nasty practical joke you play on somebody. If you set the signal 1 to test plot, then no matter what they inject from now until the end of time, they'll get the same 3 peaks. So make sure you reset it to the front signal FID, and then you will be ready to do good chromatography. So hopefully that helps. Make sure you check out the Troubleshooting GC lecture if you haven't seen that one already. And we're just putting up a bunch of HPLC troubleshooting as well. So make sure you check those out. Come on back for more great chromatography.